Alright, this is an extra example for section 10.6, and it deals with a tricky topic. It confuses some people because it leaves out part of the problem when you're reading through it. So we're going to go over this. It says the half-life of a radioactive substance is the time it takes for half of the atoms of the substance to decay. Each element has a unique half-life. Radon-222 has a half-life of 3.8 days. Thorium-234 has a half-life of 24 days. The problem says to determine K for each of these elements. Now, first thing we want to notice is that we're looking for K. That tells us we're going to use one of these formulas, either with the plus or the minus K. Okay? Y equals AE, and then positive or negative K times T in the exponent. For this one, since we're talking about decay, it's going to be Y equals AE to the negative KT. Alright? This is the formula we're going to use. We know that again because it tells us to find K and we're talking about decay, so K needs to be negative. Now the topic or the concept that gets most people confused is this idea of a half-life. Because if we're looking at this problem, it doesn't tell us how much either radon or thorium that we started with. Alright? All we know is that after so many days, that amount that we started with is going to be half gone. So here's my helpful point. This is what I want to make sure you understand, is that anytime you have a half-life or a third life or a quarter life, something where it's decaying, you choose the initial amount. Okay, which is A. You get to choose A, and you can choose whatever you want. There are numbers that are better than others. For example, a half-life, you're going to cut it in half. Something that's divisible by 2 is going to be a good number to choose. If you had a third life, something divisible by 3. Quarter life, something divisible by 4. So you get to choose whatever amount you start with. Your final amount, in this case we're talking about a half-life, my final amount is half of A. So whatever number I pick for A, Y, which is my final amount, is going to be half of that. So if I picked 50 for A, Y is 25. If I picked 2 for A, my Y is 1. I have to pick 1/2 of that. That's what my Y is. If it was a third life, I could pick 3 for A, and then I divide that by 3, and my final amount would be 1. 1/3 of what I started with. Okay? So let's go through this problem. Again, make sure you understand this concept of a half-life, where you get to choose the starting amount, and it doesn't matter what you choose. You just need to make sure your final amount corresponds with what you're talking about. Alright, so let's start with radon, 222. Now another thing that catches some people is the name 222. They'll take 222 and put that in for their half-life. That's the name of the element. It's a specific type of radon. So 222 has no bearing on the problem at all. It's just the name of what we're talking about, the substance. Alright, so we're going to fill in our formula. We have Y equals AE to the negative KT. We're looking for K. So everything else should have a value. And remember, E is not a variable. It's that constant, that mathematical constant. So I'm going to pick easy numbers. I'm going to pick 2 for A, which means Y has to be 1. 2 grams or whatever I'm talking about, half of that's going to be my final amount. So 1 E to the negative K, and then T for radon is the half-life, which we read is 3.8. Now my first step is I've got to get E by itself. So I'm going to divide by 2. I'm going to change this to a decimal at this point because it'll be a little easier to work with. 0.5 equals E to the negative 3.8 K. Now if you think back to section 10.5, we have an E in there. We have to get rid of that, so we're going to use the natural log. Natural log and E, when they're next to each other, cancel each other out. So we're left with 3.8 K equals the natural log of 0.5. Get K by itself, we're going to divide by negative 3.8. So K equals, and we're going to put this in our calculator, the natural log of 0.5, be sure to close your parentheses, divided by negative 3.8. And when we do that, we end up getting k to be, roughly, because we're going to round this to 4 decimal places, 0.1824. And there's k for this problem. That's the constant, which is specific to every element. They have their own k depending on whatever we're talking about. That's the k for this particular element, radon 222. Let's look at thorium now. And again, the 234 has no bearing on the actual problem. It's part of the name. So we're going to plug in to our formula, then we're going to solve it the same exact way. I can pick some of the same numbers. My A is, I can pick to be 2, which means my Y is 1. E, negative, K, and T in this case is 24. Divide by 2. So 0.5 equals e to the negative 24k. Take the natural log of both sides. Those cancel. So negative 24k equals the natural log of 0.5. Now, whenever you have a half-life, it should always be the natural log of 0.5 because you're starting with your initial amount. You're going to divide it to the other side. Your initial amount is twice as much as your final amount, so you'll always be dividing by twice as much. It should always be 1/2, or 0.5. Divide by negative 24. We can put that in the calculator. K equals the natural log, close your parentheses, divided by negative 24. And when we do that, we end up getting k to be approximately, or about, 0.0289. Alright? So there's the answers to those problems. Now, just like your half-life, which is different for every element, remember, k is different for every element or whatever scientific thing we're talking about, okay? It'll be different for every problem. So we've done the same problem. It's basically the same thing. We got different k's, though, and we have different half-lives. That's an example of a half-life, and the things I want you to remember, half-life, you get to choose A, and then your Y, your final amount, is half of whatever you started with, okay? Every element has its own different half-life, and in the names, don't get confused, like radon 222, 222 is not part of the problem. You could make it your initial amount, and then figure out your final amount, but it has nothing to do with the actual problem. It's the name of the element.